legacy with it.
hmm And we had 2 years where we didn't do it because of the pandemic, but otherwise it's been every year. And I take my students for hackathons there as well. And I've been there for conferences and things. So I've lived almost a year of my life at Green Bank, no more than 1 week at a time. I was
When
just
they when they
uh,
do,
go ahead.
oh, sorry. When they do hackathons, do they do like radio telescope hacks?
So we do all sorts of things during the hackathons. And we just did one. Green Bank was full. We had to go to Perry, but I'll include that in my update. But the hackathons, every student, they're all working on their individual tasks. And it's not really about being at the observatory. Sometimes we don't even use the telescopes. It's just that it's so remote and cell phones don't work and there's nothing else to do for 100 miles that, we have all the students in one place sitting around one table, no distractions. There's nothing to do. So they're going to be working 16-hour days and they can answer each other's questions, which is great. Normally you have a student just working on their project by themselves, they get stuck, and then they send an email and wait a day and that kind. But with everyone around the table, they can just answer each other's questions and just make tremendous progress. In 1 week, we get about a month's worth of work out of everyone who comes.
Wow.
Yeah, so it costs a little bit. You got to pay for the room and the food. That's another thing. Their meals provided, not necessarily the best meals ever. Um, we joke about Green Bank. They like to reuse ingredients. Like one night will be tacos, and the next night will be pizza. And so the night after that will be taco pizza, which is a unique experience. Clues knows. Clues, you've had taco pizza, right? Yeah. Anyway, so the food's provided. We don't have to worry about any of that, and we just work. It's usually you have 2 travel days and anywhere from 3 to 5 work days. If it's 5, it can get a little, by the end, you're getting a little stir crazy. But if it's 3, you're always wishing you had one more because you just know what you could get done. Anyway, it's after 3. So I'll get started with the meeting. We did not meet last week. I'll give you an update. It's been crazy busy couple of weeks for me. We met 2 weeks ago, and then we went on a hackathon, not to Green Bank, which is where I always take the students, but to Perry. Clues, did you ever go up to Perry? No, that was before your time. I haven't been up there since '05 when I pulled out of the site. Uh, we developed prompt there. The prototype prompt was at Perry. It's a radio observatory in the western mountains of North Carolina. And I don't know, it's kind of like Green Bank meets post-apocalyptic nightmare. And I'd forgotten that. I went there and I'm like, this place is scary and depressing. But by the third or fourth day, you're just, it's like there is no time anymore. You just exist in this moment in this place. And it was good. We got a lot done. Went up there with, I think, 7 to 9 students. Different, some came and left. I think at most we had 9. Got a lot of stuff done, including the tool that we'll be using today. It's mostly done. Then we came back on Sunday, and we didn't meet last week because I had the Opus MWU advisory board meeting. So prepped that, did that, went well. Cranked out 2 small proposals, 25K each. One will be for developing radio data products for Skynet 2 and to process an X-band survey of the galactic plane that I took in 2014. Similar to stuff we're going to be doing today, actually. And the other was for server hardware to modernize the servers that run Skynet and Afterglow. We did make some big improvements over the past couple of years, but we still need to increase capacity. So I put in a proposal for that. Wrote a column for Astrobeat that was in the email I sent around. Here, I'll share. I'm just dumping. Like, I haven't slept for days. I'm just, I don't know anymore. This out of the way. Oh, what the hell?
Man,
Yeah.
you sound like you drank about 3 pots of coffee today.
Yeah. Yeah, I got my coffee here. Spread you out so I can see you all. There we go. And I am recording, just checking. Yeah, I am recording. Good. Okay, so yeah, all that stuff. Wrote a column for Astrobeat. This is for members of the Astronomical Society of the Pacific, but I copied it and put a link that everyone can access if you want to learn the history of Skynet, where it came from. And this was actually, I put this off, but it was fun to write. I made a kind of a career reflection, actually starting with my first trip to Green Bank and how that kind of inspired me and how that eventually led to Skynet and then to all of our educational activities that we're doing. I turned it in and they said, Dan, this is 6 times longer than our usual Astrobeat column. And but they were kind enough to publish the whole thing. So if you have time to read a story there, it's a good story. Anyway, there's that. What else? There's a photo shoot going on here at Moorhead. I think I told you a few handful of meetings ago. The youngest woman astronaut is one of my students. Went up on Blue Origin, and she's doing a photo shoot out there and up in the dome. And otherwise, I've been working on Module 4, 4A, which we'll be previewing today. Now, this was Dave's group last year, and some of you were on that team and helped to develop this and the early version of the tool. But this is the first implementation with students. So, of course, a lot of little things change. And it was on me to write up the module, and it's kind of half written. And I'll share the full thing with you once I finish writing it later this week. I have been shooting videos as well. So if you want to do these things before the module comes out, like explore it deeper than we're going to do today, Module 4A, it's beginning to get populated here. This is the YouTube Intro Astro site with videos how to map a large region of the sky in radio, how to turn it into an image, continuum emission mechanisms, how to identify sources in your image, how to make a catalog, and then there'll be one more video on how to make a mega map. So all that, the videos are being fleshed out anyway. Okay. So those are my updates. Does anyone else have stuff to share before we dive in? Oh, Dave's here.
Hey, I just
Dave,
have one question before you get started, Dan.
was that Dave? Or no, no,
No,
that's
that
Andrew.
was
Okay. Yeah, go ahead, Andrew.
for the last, I think since Thursday, Prompt 6 has been taking observations, but no images are showing up.
Okay. I'll put that on my list.
Yeah, it's dark time and I'm working on module 3, so I'm a little stressed.
Yeah, I we're doing wrap ups for 3, and we decided to skip module 5A, Star Death, just because the dark cycles didn't line up. The last dark cycle is the last week of the semester for us, and that's not good enough. So we're doing module 7 observations now with galaxies, and I need prompt 6 to be working. So I will send that email right after the meeting.
Thank you.
What else? Dave, were you going to say something?
Well, depends on where you're going with this. I was just going to say I found another source you could play with in radio.
Another source?
Yeah, Cygnus Loop.
Cygnus Loop.
It shows up in radio.
The Cygnus Loop. You don't mean Barnard? What is Cygnus Loop?
It's a supernova remnant. It's very large.
Oh,
It's like 4 degrees across.
4 degrees. Where is it?
Okay, I don't. I'm assuming Cygnus, but I just punch it in. You know, if you add the observation, you just punch it right in.
Oh, interesting. So it's right below Cygnus A. That's map. Jumping ahead a little bit here. It's gonna be map 68.
It's just a giant source. That's all. You can actually resolve the shell.
Interesting. Let me pull this up. It's probably behind you all. Yeah, I'm jumping ahead a little bit. We'll see how to do this in just a second. Where's my folder? Map. It's down here. Should be in this map. Let's see. No, it'd be the next map. Probably one of these things down here. Well, we'll explore. That's interesting. Okay. Oh, and before jumping into 4, a couple meetings ago when we were talking about Module 2, we did the isochrone matching, and yeah, I explained that what my students do is they modeled their 3. Remember, there's 3 star clusters: a young, an open, and an old glob, and they model it, do the isochrone matching, and correct the reddening in their images, and then they hand them to another team, and the other team hands them their images. And just from looking at the images, they have to date the clusters based upon their experience with their 3. Put the 6 in order and date. And I said I'd get back to you showing how my students did. And I don't think I did last time. So it's my list to share that with you. So for module 2, here's the young cluster, the guest ages, and the age that the other team measured. So this is ages guessed just by looking. Someone's beeping my phone. Let me make sure it's not critical. Okay, it's not. It's my wife texting me as if she were the dog with pictures. Yeah, so I can wait. Young, intermediate, old. So overall, they were able to date the clusters just by looking at the dust corrected pictures to within a factor of 2.5. I don't think I shared this last time. I think I said the result would be 2 to 3, and it turned out to be 2.5 across 25 teams. So pretty exciting that module works so well. Oh, Rachel's here now too. Cool. Okay, on to 4A. Unless anyone else has anything else. Okay, 4A. So this is one of our last modules to be developed. Dave's group ran this last time, and I'm now implementing with students and writing it up. The students have already had an intro to radio, module 1B and 1C with the moon and Jupiter, and we did that. I think we wrapped that up last week, 2 weeks ago, since we didn't meet last week. But that was just kind of like a little taste. We told them, point here and make a map of the moon, of Jupiter, and calibration sources. And they made tiny little maps, 6 beams by 6 beams. That's 4 degrees by 4 degrees. So overall, all your students all together at this point have imaged just a few tenths of 1% of the sky. And they probably don't have a good intuition for radio. They built up some understanding with that preliminary exercise, but the goal here is for them to dive in kind of an exploration discovery mode. And they're just going to map a huge chunk of the sky and see what's there, as if it's being done for the first time in history. For them, it is. And that's kind of the theme of a lot of this. All this stuff's been done, but we set it up such that it feels like they're doing it for the first time. Just they're using real tools, real telescopes, that kind of thing. Anyway, so we currently have just the 1 radio telescope in the north. We'll soon have 6, both hemispheres, and we'll be able to do a little bit more. But from the north, what we do is 20% of the northern sky. And it's about 20% of the sky that can be reached from the Green Bank telescope. They can reach 75% of the sky. So overall, we're doing about 15% of the sky. And that's a big ask. That's expensive. We're going to concentrate where you have the most sources. So the plane of the Milky Way galaxy, from as far south as we can go to, as far on the other side. It's about 240 degrees across, if I remember, and about 20 degrees thick. We'll do a few regions slightly off the plane, and also one that's way up near the galactic pole, the center of the Virgo cluster. There's some stuff going on over there as well. So we do 15 maps, 14 kind of the plane of the Milky Way, and then 1 the Virgo cluster, because we live in the outskirts. And that's probably 85%, 90% of the bright sources that you can access from this telescope. Okay. And then we're just going to see what happens. So let's go through this process a little bit. Let's go to this page, and I'll share it with you. And you'll all put your name on a part of the sky that you'll be playing with today. Chat. Someone asked for, the Astrobeat link. Yeah, it's in the email. Okay, but I have it here, so I'll just, no, I don't really, yeah, I do, it's right here. Here's the Astrobeat link, just looking at the chat for the first time. Okay, now, signing up for a part of the sky, let's go here. And my students are using the first sheet. I am sharing, right? Yeah. Okay. Here's the first sheet, and teams have signed up. I have 25 teams. We only have 15 maps, so there's a lot of doubling up. Go to sheet 2 and go ahead and add your names. Everyone pick a region. Some are great. There's all sorts of sources. Some there's maybe 1 or 2 sources, and some are tough. If you get really close to the center of the galaxy, it can get too busy. Sources on top of sources all blurred together. But you all pick something to explore. We're not going to do the whole activity, but I'm going to describe the steps and you'll dabble with a little bit of each. And while you're doing that, I'll explain what's here. So the teams, they sign up for a map. They don't really know what's in it. I give some hints. Some of these have bright, famous sources in it. They're labeled by their galactic longitude, so you can see we're moving along the plane of the galaxy. Then we have 3 regions that are off the plane. And this is the information they need to submit an observation. And I'm going to demo that. Clues is laughing, but I missed what, so. Right, so Skynet. So you all don't need to put the observation in. I'll just show you quickly how to put an observation in, and then I'm going to point you to the maps my students took. Okay. So I'm gonna grab this, pull this onto the other screen so I can look at that. Slide you out of the way for a second. I'm gonna go to Skynet and just show you how easy it is to add an observation. Let's go to Skynet Live. I think the Green Bank 20 meter is jammed up at the moment, but we can always submit the observation. Gonna add an observation. I don't know, I'll do map 148. I'll claim 148. 188 is maybe cool. I don't know. I'll grab that one on the sign up sheet. Okay, so add a radio observation. Again, you don't need to do this right now, but just to show you how these maps are being made in galactic coordinates. And previously we're making our little maps in RA-DEC, but this will be in galactic coordinates. We're going to basically map the sky from here, the galactic center, moving along the plane of the galaxy. We'll get those 2 D galaxies. Oops, go the other way. Out here, we'll come down, get the Orion Nebula, and we cut off right around here. And then we have 1 extra map over here at the center of the Virgo cluster. Okay, I'm doing map 188, which is up right now. And looking at the table, it says for map 188, my galactic longitude is 188, latitude 0. Going to call it map 188. In the instructions I'm writing, we tell them to use the name that's given. This way, other students can search and find it really easily. And min sun separation 0. Basically, if the sun is going to photobomb one of our maps, it's going to photobomb one of our maps. We're not going to wait a few months for it to get out of the way. And min target elevation, it says 20. Most of them are 20. The ones that are kind of southernmost, we have to go a little bit lower, closer to the horizon to get those. And if we can, and this is one of the times a year that we can, we click observe only if the sun is under the horizon. Now, of course, we could do radio astronomy during the day, but the sun will bounce off the struts that hold up the receiver and make wavy patterns all throughout your maps at a low level. And if you want to have a cleaner map, just observe it at night. The sun passes through the plane of the galaxy in December, late December, and late June. And so this is kind of in between, so we can actually observe every map at night. Most of the time it completes. Sometimes it will terminate early. in which case you get a messed up map and you just have to resubmit. I'd say it's about 90% successful, but some maps don't work out. You just have to try again. You save here. We're doing low resolution, full spectrum, not pulsar mode. Pick something with some credits because this is a big map. Just like we have some big optical projects, star forming regions, star death, and galaxies. This is our big radio project. This will eat up time. It's expensive. This time we're in degrees mode. Before we were in beams, just doing a little patch around a source. But here we're mapping a part of the sky, and it's also written on the spreadsheet that this map, 188, it's 21 degrees in longitude and 20 degrees high. So it's a 20 by 20 map, but I have a little bit of a buffer on the sides. Catching up on the chat, laughing at Dave. Well, that's understandable. Okay, and a little bit of buffer on the sides so that we can piece the maps together into a big mega map of the whole galaxy. Direction, we map this one in latitude. We're going to map across the plane of the galaxy. This is to make when we do the background subtraction, it's a little bit nicer if we're going across the plane. And here, if I recall, I think we're doing 1/3 of a beam. We normally recommend 1/4 of a beam or smaller, but this is such a large piece of the sky. This is 420 square degrees. We want to make it a little bit cost effective. We want to try to get this under an hour. So we're going to do a 1/3 beam by 1/3 beam map. It's a little undersampled, but it's going to be good enough. And we speed the telescope up. With our little maps, we're just doing 0.3 degrees per second, but we speed this up to about 0.5 degrees per second. It's a little faster than ideal. It's going to have a slightly harder time at the turnarounds. But again, we're making compromises to get this under an hour, so it's not crazy costly. This is about $70 of observing time for each team that does it. So save and continue, and then you'd submit. Okay. That's how you submit the observation, and you wait and it comes back. But for now, I'm just going to send you to this Google directory, and you can grab the map you signed up for. Just put it in the chat. You may want to grab a couple things. The sheet of notes will be helpful, and then whatever map. And these were all done by students and named by students. Apparently, one of them has a teammate named Dylan who stinks. So the map 48 is Dylan Stinks. Anyway, I'm doing map 188. So download it, and then we're not going to put it in Afterglow yet. We're going to put it in this Astromancer tool. Those of you in Dave's group from last semester, you recall, I can slide you all up now and see all of you. And we've been making changes and debugging this daily for the past 2 weeks. It's much better than it ever was before. And kind of the purpose of it has changed. We've integrated it with Simbad. That's something I don't think was the case, Dave, when you were doing this before. So the direction has changed. It's less about this flux plot. Let's see, let me get map 188 in here. And you all load up your map. Every map will be different. You just drag it in, or you can delete and load it up that way, but I'll just drag this in. So I'm doing 188. Okay, yeah, I can do this map. The ones closer to the center will be trickier. Maybe I'll show one of those in a moment too. Are you all mostly here? Okay, good. Lots of head nods. So this is, again, it's a big chunk. It's 1% of the whole sky, which that's a lot. Couple of things here. We have a scale slider. This changes the brightness and contrast, and we're about to change the stretch mode to make it a little bit easy. For those of you close to the galactic center, you just see a blur going across the middle of your map. It's source upon source upon source. But if we use a mid-tone stretch, you can actually pull out the sources more easily. That change would be in place by tomorrow. So you can adjust this, bring out more colors. There's a zoom here. I usually shrink it down so I can see the whole thing. And then the first thing we have to do is improve the WCS. In the optical, we have stars, and Skynet takes the stars and figures out the coordinate system. Here, we just put kind of a guess based upon where we were trying to map. And we've provided some sources here. It's not every source in the image. Some of them may not have any emission at this wavelength. And there may be things like this and this that do have emission that are not circled sources. Use the sliders here to line them up. And you want to do this as accurately as possible because we're about to explore these in the optical. And remember, this is a big map. These circles are 2 beams across. So about 1.5 degrees. And so if you're off by like a few tenths of a degree, when you go look in the optical, you'll be completely offset. So line them up as best that you can, whatever sources you have. This is a big extended region. It's not going to line up super well, but anyway, do that. And we have a couple things. If there's a circled source, you can click on it and it brings up any flux information we have from a catalog Dave put together, including our observed frequency. We're observing at 1395 and it extrapolates if there's enough data, interpolates. Says this thing.
Let's see if anybody knows what source this is.
Yeah, do you know what source this is? 900 Janskis. It's one of our mains.
I know what it is. I'm just seeing if anybody else knows.
I know what it is. 3C144. Well, you can also click on the link. It'll take you to Simbad. And there you go. That's Messier 1. That's the Crab Nebula, supernova remnant. So, but that's an obvious one. What about one of these more obscure ones? They have no idea what this is. It's 3C154, and it's a quasar. Okay. So they can do a little bit of exploration. To them, everything's a fuzzy blob, but they can explore their circled sources, find out what they are. Now, we've added this really cool feature, and it's actually the primary way to explore your map. Again, the whole point of this is for them to get familiar with the radio sky. No one knows, most of you don't know the radio sky. Shame on you. No, why would you, right? But through these kinds of explorations, you too can. I know the radio sky better than the optical sky, and after this kind of exercise, you might as well. Let's do this one the other way. So click on it, but get the crosshairs as close to the middle as possible. You may have to do a couple attempts. That's pretty close to the middle. It gets the galactic longitude, latitude. It's been corrected because you corrected the WCS by lining up those circles. And now press the query. And take us over to Simbad. And let's see what we have here. So we have an image. And so what it does, it grabs every source within, I think, a quarter beam, which is 13 arc minutes. If your pointing was poor, you may have to increase that to make sure your source is covered. Or if you're looking at a big nebular region, its identifier may be outside, in which case you can increase that and submit again. In my case, I made it. There it is, the Crab Nebula. But suppose you didn't know it was the Crab Nebula. How would you figure it out? It's one of these sources. Goes on and on. There are lots of things within 13 arc minutes. So we learned during the Perry Hackathon, we're trying to figure out how are students going to navigate this chart and find something useful in here, the needle in the haystack. Slide over to references, click on it twice. You can see there are a couple sources here that have been published quite often. And lo and behold, it's Messier 1 and also the pulsar at the center of the Crab Nebula. So what are we looking for? Oh, also, it's a supernova remnant. So that sheet of notes that I said you may want to download, where's mine? It's behind you somewhere. Here we go. So I spend part of class talking about emission mechanisms. I start with thermal because they're familiar with it. We did that with the moon and Jupiter. Then I talk about these are continuum emission mechanisms. Narrowband, in module 3, which we haven't gotten to yet, but they've already started, they learned about H alpha, O3, S2 optical emission lines. They've been learning about H1, the radio emission line. These are continuum emission processes. There are 3 of them. One is thermal, which they're familiar with, and there are 2 that are really important in the radio. Everything in the radio map will either be a Bremsstrahlung source or a synchrotron source. And I spent some time explaining those mechanisms. I'm probably going to skip that today, but I have a video on it and it's written up. And but just real quick, thermal you get if it's an opaque gas, opaque anything. Bremsstrahlung you get if it's hot, dense, and transparent. So it's hot, means it's ionized. Dense, it means the charges are passing close to each other. And so they deflect each other, which emits electromagnetic radiation. And it's transparent, so it just streams out at us. So you get this in star-forming regions. So if the source you pick says H2 or SFR, or maybe even dark nebula, which is basically it's hidden by dust, it's a Bremsstrahlung emitter. This one right here is not. That's a synchrotron emitter. But I'll show you a Bremsstrahlung emitter in H2 region in just a second. And then under synchrotron sources, they know about Jupiter and sunspots because we talked about that. But supernova remnants, the magnetic field of the star gets entangled in the ejecta from the supernova. So this was a star, it exploded, and out here in the ejecta, the magnetic field is entangled, and it's a shock wave. It's accelerating electrons. Those electrons then spiral around the field lines, releasing that energy they just got from the shock wave, and that's also a continuum emission process, emits very strongly in the radio. So supernova remnants and also supermassive black holes at the cores of galaxies. The accretion disk around them generates magnetic fields along the rotation axis, and stuff can get caught up in those field lines and spit out, usually at a few 10% the speed of light. And those are big emitters. And you may see AGN or quasar or Seyfert 1 or 2 or radio galaxy as identifiers. So these are all the object types, the stuff you may see here. Things that you're looking for in that first column, if it says name, sometimes it just says name, that's a big famous source. They're just giving the common name. You may see an M, like this case, that's a Messier source. That's like the biggest catalog out there of big, bright objects. NGC, very common types of objects. If you see an NGC designation, basically you'd grab onto that designation, go to a Google page and Google it and learn more about your source. But also some good ones, LBN, Lind's Catalog of Bright Nebulae. That's useful. And SH, Sharpless Catalog of H2 regions. And you can just go through this. It's so easy. Let's see, what's this? Oh, I said it's a quasar. We checked this one out already. How about this? I have no idea. It's not a circled source. I'll try to get my thing right at the middle there. Query. Like the Crab Nebula.
Can I ask a quick question?
Please.
When you are on the map and you click on something, I'm getting the red circle with the red crosshairs, but I'm not getting the plot on the right-hand side. I'm sure there's an easy answer as to how do you enable the plotting mechanism on the right-hand side?
Let's see. It's not
weird
to do a plot. So even with the circled sources, you're not getting a plot?
No.
Interesting.
Oh, well, actually,
maybe it's down below. Is your browser?
No, it's weird because when I click on a different circle, I do get a plot, but it seems like the brightest thing in my map has a white circle around it, and when I click on it, I don't get any plots, and it's IC2177, so it's like a known source, but for whatever reason, that one doesn't seem to work.
Go ahead and share. Let me see, because I haven't seen this bug yet. And like we pushed a new version just this morning.
Can you
oh, yeah.
Turn it on?
Yep. Hey, Clay.
Here we go. All right. Can you see?
So there's a plot, there's just nothing in it.
Okay, so can you see the radio plot here?
Yeah. Oh, you're
So
doing
that,
now.
yes. What's
Yep.
that?
Okay. So yeah, I can answer your question now. So we had to add a few extra sources to the catalog. This map is the very tail end. There's hardly anything in it. I might remove it from the unit. None of them had a big famous source. Dave compiled a catalog, and there's
Yes.
nothing in this field. So we added a few sources, but we don't have any flux information. We added the sources just so you can line up the WCS.
Okay.
Like in
Well,
your
I see
case,
this note now, but I swear when my window was smaller, I couldn't see this
it may
part.
not
It
have
says,
appeared. But in your
yeah,
case, you'll want to grab the galactic longitude offset and slide it over just a little bit to line up a little bit to the right. Focus on like that source at the top, yeah.
yeah.
And then
Oh,
zoom out a little bit, maybe, and maybe down just a hair. Yeah, okay. Now you can click on something, click near the center. Yeah, you have to, yeah, that's good. And now query. Let's find out what that thing is.
right. So I got the query to work, and then you hit this. Uh,
Now the query is only good if you get the WCS lined up and you hit near the center. So there you go. You got something 55 references.
yeah,
And in
or
this
C.
case, you have 4C and the O type is rad, which means it's a radio source. They don't know what it is.
Okay.
Sometimes if it just says rad, I guess I was getting to that in my table. Here, I'll share again. So you won't
Yep.
be able to learn too much more about that particular source.
Okay.
You got
That's
the worst
helpful.
map.
Thank you.
You're in the worst map. Let me bring this up again.
My map is not, well, it's one that's right along the plane and it doesn't have much for point sources outside of the plane. I'm
Yep,
not
go
getting
ahead and
great
share.
alignment either.
Go ahead and share. Let's see. The
Okay.
ones in the plane are really tough.
Yeah, I am. Let me see if I
And
can.
there's one in particular that's really, really tough.
If I could find the screen share button. Okay, where is that these days? Did they move that or am I
It's
just
on the zoom bar, in the middle of the zoom bar. Uh, so one thing I can't show you over share. They hide the zoom bar over share.
Oh, there it is.
It's
Okay.
the
Hold
green one in the middle.
on. Okay.
Yeah, this map sucks, but try the big bright source. Well, first of all, we're going to have a new stretch mode that will make it easier to see the sources on the plane. It helps bring them out. But looks like you have it fairly well lined up. Click on the center of that bright source in the middle. Yep. And maybe down just a little bit. It's really sensitive when you go to Simbad. Okay. It's 3C 400. Go ahead and query. Let's see if we can figure out what this thing is. In the plane, sometimes things are bright, but sometimes there's nothing in the picture that comes up because it's hidden by dust. Okay. Slide over to references on the table. Yep. And then click on the top, the very top, the column header, and click on it again. Okay, so you got something famous in here. Slide to the left again. And usually you can also slide with your mouse. And we got a couple things here. W51, supernova. They're the same thing, I'm pretty sure. W51, supernova, whatever. Many of these things are the same thing, they get different names in different catalogs. So you discovered a supernova remnant, and it's kind of one of the brighter ones. So I think it's like 400 Janskis or something.
Okay. Good. This is a lot better than what I was getting before.
Yeah. And if you Google like W51 radio source or that supernova designation, go ahead and copy that. Let's see what happens. Go to a fresh tab and search on that. You may have to add radio source.
To go to image.
Yeah, yeah, maybe image.
So is
Uh,
this what we're,
didn't give too much. Try Googling on the supernova designation instead of W51. There may not be too much because I think this one's hidden by dust. And try the main list, not the images, but the main source. So I didn't see anything in the picture on Sinbad. So that means this one is known in the radio, but not the optical. Yeah, you may have to dig a little bit. It may be hard to find information. If there's no optical counterpart, it's harder to find information. But at least you found out it's a supernova remnant.
yes, that's
And that's
better
kind
than I
of
had, and just the alignment was not real obvious. I only had basically the one thing that I could tell what it was supposed to
Mhm.
line up with, so.
Now you can work your way along the plane and find some other things. So here's some other things. If there's a star in the object type, that means it's a star, and they're too faint to see in the radio. So anything in your list with a star, that's not it. If it says RAD, it's just unknown, some radio source. What else do we have? Yeah, and I was going to show you some more. So I don't know. We're going to try this one here. What's this thing? There's something. I can see my picture. See the nebulosity around there? So what, and I'm pretty well centered. So if I sort by references, yeah, the first thing's a star, but right under that we have H2 region. And there, this has names, so it's a famous thing, Lowers Nebula. So I can learn more about it just by searching around. It has a says it has a sharpless designation on that Google search said that. I'll do one more here. I think I demoed this last time because we were working on the tool. Query. Okay, there's clearly something there. I'm a little bit offset. So, if this doesn't yield the answer, I may have to expand my search region. NGC 2175, I think that's it. So one of these things says NGC 2175. If it was outside my search region, I just expand this, maybe make it 26. A little bit slow. The NGC 2175, search on it, and it has a Wikipedia page. And this is the Monkey Head Nebula. And I found that exciting when I was doing it because window. That's my Module 3 optical project this semester. The students all picked one, and I picked one, and I'm doing Monkey Head. I think I saw it. No, I didn't see it. It's probably down here. I showed this last time because I'm excited with how it's coming out. There's my image of it, and there's my infrared enhanced image of it. And we'll be learning how to do this next time and what you can calculate with that kind of stuff. And so you can explore. And basically, they're a team of four, so they can divide up all the sources. Some of them, they won't figure stuff out. Some it's just noise, but that's probably a source. That's a source. That's a source. This is something. And they go through and they put together a source catalog. So here my student source catalog. Here, I'll close some of these Sinbad pages. And it's quite a source catalog they're putting together. And some of them are doubled up because they have two teams doing the same field, so they're finding the same things twice. And some of these are wrong. I don't think planetary nebulae emit in the radio, but lots of star-forming regions, quasars, supernova remnant, H2 regions, dark nebulae. They're getting a feel as a class for what the radio sky has. And some of them are famous objects. So when they write their blog, here's Starship Sigma. They did map 28. They found what, 8 or 9 things. And they'll be able to talk about some of them in their blog and talk about what's typical out there. Okay. So the last thing we do, and we're all going to do this together, and we just got it working last night. So if you come back to the Google page, download the corrected.zip. So basically, these are maps. So imagine you all did your maps. You did the WCS correction. After you do the WCS correction, you can save the FITS file with the corrected coordinates. So now all the maps are in the exact correct position. And there's going to be 2 buttons where you can download the full FITS file or just that one layer that we're interested in. We don't have that yet, but I stripped out that layer. So download the corrected and go to Afterglow and upload that. Now, I'll show you kind of how. I'm working in Dev Afterglow because we fixed a bug, but you can do this in either. Let me just get all this stuff out of here. So you'll have to download that, unzip it. Don't upload the zip file into Afterglow. And you go to your workspace, and I recommend that you add a new directory, call it something like map 2025, and then put all your corrected maps in there so they're all together. And once you have them, load them in. It's not the best brightness and contrast scaling. We'll fix that in just a little bit. But you can see all the maps that everyone's working on. While you're doing that, I'll just give you a preview. There's map 8. Here, one second. I'm going to link the display settings and give them all better display settings. Midtone, default. So here's the center of the galaxy map, all sorts of stuff going on in there. Now, I'm just doing this as you're loading in. Here's the next map out, map 28. There's that 3C400. Oh, kind of fun in this right here, that's Kepler supernova. So there are all sorts of gems in here that they'll find as they're searching. Map 48. Oh no, that's 3C400, my bad. Map 68, we're working our way out. That is Cygnus A. Map 88, we have this blob. This is our arm of the galaxy. We're looking down it, so you're seeing lots of stuff. Then after that, we have map 108. And there's Cass A. Little star-forming regions. If you look these up, you find most of these are star-forming regions. Map 128. Working our way along. There's stuff in here. Then 148. This one looks a little different, but there are a few sources in here. Map 163, we have some that I made a little bit taller because there's some interesting stuff above and below. Some quasars and things in here. 73. 188, that is the crab. And IC 443, I think. And then 208. Can't remember what that is.
Rosette. It's the Rosette. That's the one I had.
Rosette. That's the Rosette. That's right. And map 228, there's not much here. This was map. If we go a little bit below, have Orion. Here's Orion A, Orion B. I just learned by doing this, Orion B is the Flame Nebula. If you know the Flame Nebula, it's a radio source. I never knew. And above the map, near the center, we have these 2 radio galaxies. And then way off in the corner, we have the center of the Virgo cluster. Does everyone have the images in Afterglow? Okay, this should be easy, though. Let's see what happens when we all do it simultaneously. Once you have them all here, go to the Aligner tab, 3rd from bottom. Select all your images. Hopefully you cleared everything else out before you loaded these in. If so, you can just select all. We're going to do a mosaic. And turn off rotation, turn off scale. These are not like optical cameras on telescopes that may be tipped over or different scales. These are reconstructed maps. They are perfectly in the coordinate system. They don't need to be rotated, scaled, or skewed. And we're doing WCS alignment in mosaic mode. It should go really fast. Select all the maps. Sometimes you may not want to include Virgo because it's way off by itself, but it doesn't really hurt to include it. Because they're WCS'd, they'll align very quickly. Now I'm in dev. Production currently has a bug. We fixed it in dev. So once you align it, it replaces it with the full size and shows you where your map is in it. But if you're on production, it's just going to be a white block with rotating circles until we push this fix over. But then it will do this. So you see where these pieces are lining up. I'll do just one more here. Here's map 68. It should be over here somewhere.
Dan, mine is doing that. So they may have pushed the fix.
Maybe Vladimir has woken up. He works nights, so. Okay, and lastly, go to the stacker. Select them all. It can be default everything. Average, nothing fancy, everything turned off. And it will stack these now aligned images into a single image. So Clues, you're always telling me that my 30-year-old radio cartographer software has to be replaced. And you can see
Yes,
we're almost there.
I know. This is exciting.
And this is why it's taken so long, because we're doing it the right way.
Implying that the old way was the wrong way.
Yeah.
But it was the only way, Clue.
It was the only way for 30. It got us through 30 years. And this is using the new radio cartographer algorithms, the ones we published a few years ago in AppJ. When you stack it, it will make a new image. It's down below. It's probably called converted_stack. And you can load it in, and it's full resolution, so you can zoom into any part. And the students have just done a survey of a big chunk of 15% of the sky, 15% of the whole sky. So you can really see it. There's the center of the galaxy, those D galaxies up above. As we go away from the center, it gets less busy. This is where we're looking down our arm of the galaxy. Sig A, Cass A, Taurus A, IC 443. It's a supernova remnant. Here's the Rosette. Here's Orion, Orion B. And then way up, over here. And we're still working a little bit on, this got trimmed, and we don't want it to be trimmed. So we're working on that. But here's Virgo, Quasar 3C273. The first cosmological redshift was this source in the optical. And some other little galaxies that they can identify using Reese's source finder tool. And so what I'm going to do is I'm going to take their sources and their source count. I'm going to print this out on a giant scroll of paper. I'm going to mark all their sources on here with little arrows and names and what they are. The last day of class, I'll bring it. They can all sign it. I'm going to hang it in the hallway.
Can you pick another color scheme though?
Yeah, we'll have to.
Yeah, we like to taste the rainbow sometimes, but do we have
Yeah.
to do that?
This is my go-to with the radio. You may like
And
Reese's
it
better.
still looks terrible.
That one looks better.
He puts blue at the bottom.
Yeah, I put blue at the
We
bottom.
can get him to put this, we can get someone to put this palette into Afterglow. It's just not one of the Afterglow palettes at the moment.
I recommend the heat color map. That looks awesome.
Does it? Yeah, so let's
Wait,
find out.
no.
It does.
Oops, that's Bomber. You get a
There
little
you
bit
go.
less definition with these single palette maps.
Mm,
So often with the radio, since everything's blurry, I get the definition by adding a rainbow. So you have lots of color definition. Oh, and when you're here, I forgot to tell you, change your stretch mode to midtone and then hit the default preset and you'll get much better definition on your image.
Tell you what, why don't you hit invert and see what happens?
Yeah, I'll go back to linear default. See, that's what it looks like in with linear. But if you go to midtone and hit default, then you'll have all the definition you want to see all those little sources. And this is something radio astronomers do. They map big chunks of the sky and collect all, extract all the sources, match them with other catalogs to identify what's what. As part of this little grant that I put in over the past 2 weeks to build the radio pipeline tools for Skynet 2, kind of like the Green Bank data products, but they'll work for every telescope. I said, well, analyze this X-band map. In 2014, they had their X-band receiver, which is 9 gigahertz. So it's like 5 or 6 times less blurring because the higher frequency. And I mapped 1,000 square degrees of the sky, 100 degrees by 10 degrees. And I didn't know if it'd be of any value. I still really don't know. But talking with chat, at that wavelength, people have only done targeted observations. No one's actually mapped a whole big chunk of the sky and extracted everything. And I'm looking at Dave to see if that sounds right. But that's what chat tells me. And so
I guess.
it could be an interesting data set. And we had the green bankers pull hard drives out of closets to go recover that data I collected over a decade ago, and we'll process it. But anyway, this gives the students an idea about how to, what's in the radio sky. What is radio? What's it look like? What kinds of sources? So here's a chance to talk about emission mechanisms for them to have a search and discovery and become familiar with it. The new tool with Sinbad, I think, is awesome because it can connect it to optical. As long as you get the WCS right and you click in the center of the sources very carefully, it seems to work pretty easily. And they learn how to build a source catalog. I forgot to say they go back and then they photometer everything. They come in here. I think, let me just check if I have my radio photometry settings turned on. I'll demo this. You may remember from the moon exercise and Jupiter exercise, we have different settings here, but they build up a source catalog. They go and they fit all the sources that each team discovered. It's, source catalog with brightness information. So they extract brightnesses and then they calibrate it to Cygnus, which is also in the map. And so they're producing not just a list of sources, but their brightness in the radio. And a lot of them should be the same as it ever was. What song was that? Now I got the earworm.
Talking Heads.
Talking Heads, yes, thank you.
Yeah, there you go.
Very good.
I'm thinking the same thing.
Yeah. I got the video in my head, right? That's a weird video too. Mm-hmm.
Same as it ever was.
Thank you. Very good. I was going to do that, but I didn't have the nerve because I knew it'd come out bad. But
that's all right. I make full of myself. Thank you.
So but some things like quasars and AGN, the brightness can vary by factors of a few over time. And so they're actually collecting potentially interesting, valuable information if anyone wants to study these things through time. I think it's a good introduction to not just an intro like in Module 1, but like really starting to learn the radio sky. I'm pretty happy with this, and we do the mega map tomorrow. I'll shut up.
Hey, as a side project, have you considered having over time either a group or an instructor map the boring parts of this so that at some point you can make not just a map of the good parts, but the whole thing?
Yeah.
Everything visible from Green Bank.
It may be hard to get the WCSs right if there are no sources in there.
Yeah, but if there are no sources, it kind of doesn't matter if
That's
they don't.
true. That is true. And actually, this aligned and looked just fine even without the little WCS tweaks. They're all off in, it looked fine. The offset's mostly in right ascension because the map wasn't taken at the epoch of, J2000, right? And so you got to shift everything a little bit. Is that right? I don't know. Everything seems to be shifted in the time coordinate. and a little bit in the up-down coordinate. That's probably because of our time shift corrections not perfect. I don't know. But yeah, you could do the whole sky. It's going to cost a lot of credits.
Well, that's why I'm saying you could do the boring bits kind of
Yeah.
one here, one there, and then eventually you've got this extra folder of, okay, here's the map you guys did, here's the extra bits. Now you've got the complete picture.
Mhm. I'm looking forward to this X-band map. As I recall, it's clean, lots of sources, and it's very wide. We should be able to split it into red, green, blue and make a true color image with the X-band map. It should be a lot of fun. But I mean, that's not going to be in the class. It's something my students will do this summer. I don't know if this helps you all love radio as much as I do, but I think it's a fun exploration. Any other thoughts? Okay, so this is the big radio project of the MW sequence. Everything else for using radio, little ways, supplementary ways, but this is the big one.
Yeah, I got a map of Cygnus loop if you want to share.
Oh yeah, I'll stop sharing.
If I can figure out how to do it again.
I talked about my lack of sleep. I don't know if you've noticed throughout this, I've been alternating between Coke and coffee. So, what the hell is that?
This is Cygnus loop. Well, this is weird.
Oh,
This is
okay.
where I have to get a question for you, is because that's right. That's RA long, and that's X and Y separately. So I've processed X and Y separately, right?
Okay.
And then this is declat, and declat is a little weird. But the thing is, the general shape, actually, the outline of this source looks like this.
Yeah.
And then I started playing. And so this is X minus Y in
Okay.
the RA long. So this is Stokes Q. And then this is Stokes Q for declat.
Ah.
And I've just been playing with this source a little bit. These are two others, but the Stokes Q tells me that I already know what the polarization looks like for this thing. So it's actually highly polarized to the south, and there's a bit to the north as well.
Oh, this is interesting. We'll have to play with this.
And I want to see about playing with this a little bit more. I don't have time now, so I'll be working on it probably in early summer. But I want to try to map the polarization of this thing if I can.
Here's one recommendation. Since it's extended, a 6-beam subtraction may be too small. 6 beams for point sources. You may want to try a longer, like 8 or 9 or 10.
Yeah.
Try some longer beams.
Because this is about 8 beams, maybe.
So this is one of the messy things underneath SIG.
Yeah. It's in that region.
Which map was it again, Dave?
This is Cygnus
Group.
loop. This is a single source.
No, I mean of
If
the
they're
in the
available.
list.
If not, I'll help you. I'm done in a minute.
I
Sorry.
meant in the list. Was it one of the numbers or not? Maybe not. Okay, never mind.
So
I
Dave,
don't know.
which
I
one?
don't remember what galactic longitude it's at. I was going to look it up.
What is it? Here's Cygnus. I assume is it this whole thing right here? Or is it like one of these things?
I think it's that thing.
This big thing right
big
here?
one.
Well,
this?
I could try pulling up coordinates right quick to see what it is.
Oh,
It's in
well,
your-
in
it's
the
in-
mega map, the coordinates are all wrong. We haven't
Oh.
figured that out yet. So I'd have to load up. I can load up an individual map.
I'm going to look up its galactic coordinates.
Well, I was mostly just curious where it was in the big stacked map. But what was interesting to me looking back at Lauren's rosette and then the whole thing was the different scaling makes the colors look really different because initially naively I was trying to match it up by colors and then I was like, oh no, because the colors are what's red in the map 208 is not red in the combined map because it's not the brightest source.
Right. Like 228's faint stuff.
It may not be in your map at all, Dan. It's at 74 minus 8.5.
Ah, 74. Oh, it's this
There you go. That's it.
right here.
It's
That
sitting
looks
on,
like
yeah, it's sideways. Yeah, that's it.
Now it's
You
at the
got it.
edge of the map, and edges will get screwed up because our turnarounds are poor, so it looks a little
That's the
screwed.
general shape. It looks like a weird ear.
Interesting.
So you did get it.
Yeah, and it got the background subtraction algorithm tears things up at the edge of maps as well. But yeah, there it is.
Still amazed though. You still got
Yeah,
it.
so maybe we'll do a green bank project and a Ryber project on that, particularly if it's polarized.
Yeah, that was the thing I was going to explore before going to Aurora this year, was just make sure, because this is polarized. This supernova remnant, it's polarized. We're resolving part of its shell by doing this.
And
Because
polar,
if we're looking at the North Polar Spur, which is just much larger, I was thinking something a little smaller, but still big
yeah,
enough that we could resolve it.
yeah, I'm getting tired of the North Polar spur too hard.
It is
But
too hard.
that's cool. And remember, we're soon going to have telescopes with S band and C band, and it'll be able to resolve this much better than L band, which is blurry.
It's in the map 68 Colson, if you want to click on that one and zoom in. And it's actually the same, near the same colors. So it's, yeah, right there.
Let's see, this is my aligned version. Yeah, one thing I could do is extend this map a little farther south to maybe get it in a little bit better, since it's a source of interest.
And if I'm not mistaken, Cygnus Loop is also visible. It's also visible.
Oh, absolutely. That's where the Veil Nebula,
That's the Veil
the
Nebula.
Eastern and
Yeah.
Western Veil, and there's actually multiple sources in there. There's a big knot, and there's at least 4 or 5 galaxies, I think.
Yeah, let's pull map 68 in here. Yeah, it's way down here at the bottom. That's why I wasn't paying attention. So this is one where by querying Sinbad, we should see it, but I may have to expand my reach. Yeah,
Yep, there it is.
Yeah, it's
There
like
it is.
it's like 3 degrees across. So
yeah.
It's huge.
And so if I search looking for it, I may not get the identification. No, it's saying quasar, but I'd have to expand this.
Yeah. There's a lot of sources in there. You see Pickering's Triangle off to the right there.
Yeah. Yeah.
And then you see the Eastern and Western Veil.
Oh, this is the Veil Nebula.
Right.
Yes.
Okay. So it's still loading. When I went from 13 to 60.
Oh, it's going to be so full. So it's so big. It's like
Yeah.
3-4 degrees across. It's ridiculous.
So it loaded. Still trying to load the
If
picture.
you're looking for a radio, anything, you're not going to see it right off the top.
And it's still not covering the full veil.
Mm-mm.
And sorting is taking a while, but okay, 933
There it is.
Cygnus Loop Supernova Remnant. So sometimes you do have to expand. If it's an extended object or if you did a poor job with your WCS and clicking. But isn't this cool? You can explore and say, what is this thing? Oh, well, it's this. It's the veil. Anyway, we're over. Happy to stick around and chew the fat with anyone who wants to. But anyway, if you want to get familiar with the radio sky, that's the way to do it. But maybe do a map or two on your own if you want to play. I wouldn't do the whole thing until you have students because it is costly. You don't want to just do this all the time.
Yeah, I'm gonna have to figure out how to scale it back since I probably have a smaller class.
Yeah, and so what I'm recommending in the manual is each team take one or two, and then they can grab the other ones on Skynet just by searching for like map 188, and they can take one
Okay.
someone else did.
Yeah, so just get them used to.
Yeah.
Then I'll come begging you for more credits.
Yeah.
Again.
Well, that's what I was going to ask. How do you feel about us just using this corrected .zip file?
Yeah, you could just take that. That's this year's corrected And I'm trying to streamline the process. The students will be able to get to that themselves. But anyway, it's a little messy this year. It's going to get cleaner. And I have the videos that I pointed out at the beginning. I'll have written instructions by the end of the week. Take whatever maps you want. All these activities can be run archivally.
Yeah, that helps when you've got like problems that pop up, right? So it happens. I mean, it just happens. So,
Yeah. All right. Well, if there's nothing else, next time we'll get into module 3, astrophotography, advanced level. So luminance filters, narrowband filters, and even if there's time, archival searching, though maybe we'll separate that, do that in 2 separate meetings. Maybe I'll
Yeah,
show
I
you
wanted to ask a super quick question about Erira if you have a sec, but I don't know if it's of general interest.
Yeah, so we'll adjourn the meeting and I'll stop recording and I'll see most of y'all next week.
Thank you.
Thank you, Dan.
We'll have a little Erira discussion for those.